Mr. Xenakis went for a jog, looping around his neighborhood. He jogged the first 0.75 miles in 5.25 minutes, and then walked the remaining 0.75 miles at a pace of 4 miles per hour to return home. A. What was the average speed for the entire trip in meters per second? And B. What was his average velocity, again in meters per second? All right, so after reading through the problem for the first time, you want to go back through the problem and break down all the different variables that are in there and make sure that you're answering the right questions. Okay, so part A actually says what is the average speed for the entire trip in meters per second. So a good starting point is to identify what is the equation for average speed in variable format. Remember, you always want to identify your equations first in variable format. Okay, so we have an equation here for average speed, which is the total distance divided by the elapsed time. Let's go through and actually identify our variables. Well, if we break up the total trip of the jogging portion and the walking portion, we can know that both D1 being, we'll use 1 for the jogging and 2 for the walking, D1 and D2 are actually the same at 0.75 miles. Time 1 for the jogging was 5.25 minutes, and the overall speed, average speed for the walking portion was 4 miles per hour. Now be careful. In these types of problems, what students often like to do is, well, if I find the average speed for the first portion and the average speed for the second portion, I can just average those two together. But it doesn't really work that way. Let's think about this example. If you were driving for an hour and during that time, 1 minute of the hour you drove for 50 miles per hour, but the other 59 minutes you were driving 5 miles per hour. Could I really just take the 50 miles per hour and the 5 miles per hour and average them together? Would that be representative of my average speed for the whole hour? Well, no, you can see in that example that it should be a lot closer to 5 miles per hour since you were going 5 miles per hour for 59 minutes. So the same is true here. You have to really be careful. It's a weighted average of the time that you spend at the different speeds. Okay, and so what you need to look at is the total distance, and the total elapsed time will give you your overall average speed. Okay, what we're also aware of is that we have to find the answer in meters per second. So I've identified some conversion factors. 1 mile is 1.6 kilometers, 60 seconds being in 1 minute, and 60 minutes is equal to 1 hour. Okay, so now that I've gone through the problem and I've identified some things, let me go back to my original equation and start to work it through with the variables that are part of this problem. In this case, the total distance is going to be D1 and D2 added together, divided by the total time, which is T1 and T2. Now I know all these variables except for T2. So let's go ahead and work and solve for T2. So reworking the speed equation, we can find that T2 is going to be equal to the distance 2 divided by the average speed 2. Plugging in, we find that 0.75 miles divided by 4 miles per hour. The miles will cancel out, and we're left with 0.1875 hours. The hours unit flips back to the top of the fraction here. But T1 is actually 5.25 minutes, so we need to get these units in the same units. So let's just go ahead and convert here to minutes, 60 minutes in an hour. Again, notice that the hours on the bottom, because I want to cancel out the hour and be left with minutes, so be mindful of that when you're doing unit conversion. And I find that 11.25 minutes was my time for the walking portion. So I'm going to plug this back into my equation for average speed, and I have find that the total time was 16.5 minutes, okay? But I want to convert back to meters per second. So if I look at my unit conversions here, I have 1600 meters, or which is 1.6 kilometers. I just made that conversion here just to streamline things, but it's 1600 meters in 1 mile and 1 minute and 60 seconds. Again, make sure that you're placing the right unit in the bottom or the top of your fraction here for your unit conversion factor. Okay, the miles need to be on the bottom for the conversion and the minutes on the top so that they cancel out, and what we're left with is meters per second. So the average speed then for this whole trip in meters per second would be 2.4 meters per second using two significant figures. So where does that leave us then with velocity? I know that velocity is both magnitude and direction. So do I just then take that 2.4 meters per second and add whatever direction I went in? Well, I don't really even see any reference to direction. Okay, so let's go back and start with our equation. We do have an equation for velocity. Remember, velocity is a magnitude and a direction, but it is not based on distance, it is based on displacement. So we have displacement divided by the change in time. And notice that I didn't say that the velocity average is just delta x divided by delta t. I'm talking about these variables and describing what they are. It's the change in position or displacement divided by the time elapsed or the change in time. You need to get used to talking about the variables for what they mean so that we understand them and it's not just letters that we're just using on the screen or on the board. Okay, so the total elapsed time is really the same. It hasn't changed. You add the two times together, and we're going to convert here again to get into seconds, and we have 990 seconds. But really what differentiates here is the fact that we're dealing with displacement. That's what's making it velocity as opposed to average speed. And in this case, our displacement, or change in position, was 0. We didn't go anywhere. We started at the house, and we ended up back at the house, which then means that we didn't actually go anywhere. Regardless of how long it took us to get back to our same position that we were in, the velocity is going to be 0 meters per second. And then again, if you compare this to the 2.4 meters per second for your average speed, you can see that velocity and speed are not the same thing and need to be treated as such differently. Thank you, and I'll see you soon.